Hello, Dan here from howtomechatronics.com. In this video, we will learn about Coulomb's law and we will take a look at some simple examples. This law was first defined by French physicist Charles Coulomb in 1785 and was essential to the development of the theory of electromagnetism. Coulomb's law is a law of physics that describes the interaction between electrically charged objects. It quantifies the amount of electrostatic force that two charged objects exert on each other, which causes an attraction or repulsion between them. Like charges, for example two positive or two negative charges, will repel one another, and unlike charges, one positive and one negative charge will attract one another because of the electrostatic force. Specifically, this law applies to point charges. Any objects can be treated as point charges as long as they are very small compared to the distance between them. Also, the force is along the straight line joining these charges. We already know how to measure electric charge. This can help us calculate the electric force between charged objects. So, this equation shows the magnitude of the electric force between charged particles. F is equal to the product of the two charges Q1 and Q2 divided by the square of the distance between them R and then multiplied by the proportionality constant K. The electric force is expressed using the unit Newton. The reason why the distance is squared is because when the distance between objects doubles, the force between them reduces to a quarter of their original value. In other words, the electric force between two objects increases as the distance between them decreases, and opposite, the force decreases as the distance increases. The lowercase k is called proportionality constant or Coulomb's law constant. The value of this constant is dependent upon the medium in which the two objects reside. In case of air, the value of the Coulomb constant is 1 divided by 4 pi epsilon naught, which is approximately 9 times 10 to the 9 Newton meter squared per Coulomb squared. Epsilon naught is called the electric constant or vacuum permittivity. If we compare the Coulomb's law to the universal law of gravitation, we can notice that they have some similarities, but they work in completely different ways. The electric force is much stronger than gravity. From the equations, we can notice that they have different proportionality constants. In the equation for gravity, we are using mass to find the force, but here we are using charge to find the force. Thus, the gravitational force is always attractive, depending on the mass of the objects, which is always positive, and on the other side, electrostatic forces can be either attractive or repulsive, depending on the charges, so the result can be negative or positive respectively. To sum up, Coulomb's law states, the force between two like point charges is repulsive and between two unlike point charges is attractive. The force direction is determined by the line that passes through both charges. The magnitude of the force is directly proportional to the product of the two charges and inversely proportional to the square of the distance between the charges. Being a force, the strength of the electrical interaction is a vector quantity that has both magnitude and direction. This means that we can calculate the magnitude and the direction of the electric field based on the sign of the result. Let's modify the equation. The arrows in the equation represent a vector quantity. This sign means that this is a unit vector pointing from Q1 to Q2, and the index 1, 2 means that Q1 exerts force onto Q2. If we get a positive value, it means that the direction of the force is repulsive. On the other side, the minus sign means that the direction of the force is opposite or attractive. Let's say we have two positive charges. The first charge, Q1, is 2 times 10 to the minus 2 coulombs, and the other charge, Q2, is 1 times 10 to the minus 3 coulombs. The distance between them R is 1 millimeter, which is 1 times 10 to the minus 3 meters. Now we can calculate the force between these charges using the equation. So F is equal to K multiplied by the product of the two charges Q1 and Q2 and divided by R squared. Here we can cancel out meters and coulombs, which means that we are left with newtons. This is 18 times 10 to the 4th divided by 10 to the minus 6th, which is 18 times 10 to the 10th newtons. We got a positive result, meaning that the charges repel one another. In case we had one positive and one negative charge, we would get a negative result, which means that they would attract one another. If there are multiple point charges, let's say 3, we can calculate the force of the two charges that acts on the third charge. This leads us to the superposition principle, which states that for all linear forces, the total force is a vector sum of individual forces. This allows the Coulomb's law to be extended to include any number of point charges. In other words, the total Coulomb force from a system of point of charges acting on a point charge can be found by adding up the forces from each of the other individual charges. Here's an example. We have 3 point charges, Q1, Q2, and Q. And we need to find the force that Q1 and Q2 exert on Q. Q and Q1 are positive charges, and Q2 is negative charge. The force that Q1 applies on Q, F1, is repulsive, and the force that Q2 applies on Q, F2, is attractive. The total electric force F is a sum of the two forces, F1 and F2, and is represented with this vector, F1 plus F2. So that's all for this video. In the next basic electronics video, we will talk about the electric field. Thanks for watching, and I hope this video was helpful. Don't forget to subscribe, and for more tutorials visit my website howtomechatronics.com.